Section 5. Section 5 for Unit 1. Does everybody have a copy? What we're going to do now is, and this is, you guys, this is why domain and range gets so important. We are going to now do what's called domain-restricted graphing, where instead of taking an entire graph, the entire thing from left to right, we're going to take a piece of that graph. And in order to take a piece, we need a way of describing which piece we want. And we're going to use domain for that. We're going to say the domain from here to here, that's the chunk of the graph that I want. And so we're going to graph it. Really, you guys, this shouldn't be any harder than what you've already done. It's putting together pieces you already know. And really, in some ways, it's easier. You're doing the same graphing techniques, just with only a piece of the graph. That's the only change for today. However, if you're still struggling with some of the graphs, so we'll try to spend some time on the exponentials and other ones that we're struggling with. But hopefully, when we get like a straight line or a quadratic, they shouldn't be hard as long as you understand how domain works. So a few important things. First off, it says recall, domain represents the, what part of the function is the domain? The x values. Represents x values of the function. So sometimes functions have the domain restricted to be a subset of the original domain. Just means we're taking a piece of it. In order to plot it, then what we're going to do is find some important points. Kind of decide where your starting point is and where your ending point is. Make sure you have those points. If there's a vertex or something else, an important point that you know you have to have, make sure you get that one. And then the rest of it's just graphing in between that beginning and ending point. A couple of extra things here. An open circle. Put those down for the beginning and ending point if the restriction is less than, greater than, or not equal to. So any place where we're going to start there or have, essentially skip over that point. Use a closed circle if you are including that point. If there's an or equal to, use a closed circle. If there's just a less than or equal to, you're going to go ahead, left. If there's a less than or equal to, you're going to the left of that point, wanting the smaller values. If there is a greater than or equal to, you want to the right of that point so you can get the bigger values. If it's a equal to, or sorry, not equal to, you're going to just kind of skip that point and go left and right. And if you just want like y equals 2, you're just going to put a point. You're not going to go on either side of that. Does that make sense? You'll see it in just a moment. So let's try this. F of x equals negative x squared. Okay, here we've been using like different colors and other things as we've been graphing. I'm going to show you a couple different ways. If you want to use a pencil, it would actually be a good idea for these so that you can erase the parts you don't need if you accidentally graph them. Okay? So here, having a pencil would be a good idea. Let me see if I have one. There we go. So let's try this. I'll show you again. You can use some of the rules to be a little bit faster than what I'm about to do. This is the long way, but it works. F of x equals negative x squared. Okay, negative x squared, I know what that looks like. That has a vertex at 0, 0. And if I put in 1, 1 squared would be 1, and then made negative 1. Have a mirror image. If I put in 2, 2 squared would be 4, and then we would make it negative 4. Does everyone think they could graph f of x equals negative x squared? Any questions about that general graph? So normally we'd put those points down, we'd connect the dots, and we would make our graph. Does that make sense to everybody? Now, the general format for these questions is they're going to ask you about one of the important points. So they say, okay, what is f of negative 1? That just means plug in negative 1. So I plug in negative 1, becomes positive 1 when I square it, negative makes it negative again. It's this point right here. We plugged in negative 1, we got out negative 1. That would be the answer to that first question. F of negative 1 equals negative 1. So we put that down. It corresponds to this point right here. Then it says graph f of x if x is greater than or equal to negative 1. So, looking at this then, that's the critical point. That's the negative 1 that we just found. It says x is greater than or equal to. Where are the x values bigger than -1? To the left or to the right? To the right. Is everybody clear with that? And in fact, if your variable is first, this is going to point the way you want to go. Okay? Does everybody see that? We want bigger values to the right. So all I have to do then is erase the part of the graph I don't want. This is why you might want to use pencil. If you don't use pencil, you'll just have to be careful and not graph the whole thing. Because that was extra work. There's no reason for you to graph the whole thing and then erase part of it. You could just say, oh, I need to start at -1, and I'm going to go to the right of that. So boom, 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 you get those points down, you graph the entire graph after -1. Does that make sense to everybody? That is the graph of f of x equals -x squared, where x is greater than or equal to -1. We're done. So the next one, I'll show you how to do this one without erasing. This one, f of x equals x minus 3 squared minus 2. It's another quadratic. It wants f of 4 to start with. So let's plug in f of 4. 4 minus 3. Actually, I'll go ahead and write it off to the side. 4 minus 3 squared minus 2. 4 minus 3 would be 1. 1 squared minus 2. Is everybody good with that ending up being -1? 1 minus 2 would be -1. So I have the point 4, -1. It wants me to graph x is less than 4. Okay, so I'm going to put that point down. That is the point that they just had me find. They're having you do the work in pieces. It's not just random here. These will always match, pretty much. They'll always be at least one of your important values. So we've got f equals -1, or f of 4 equals -1. 1, 2, 3, 4, -1. Here's the point. Am I going to put a solid dot there or an open circle? Open circle. It doesn't tell me I can equal 4. Does everybody see that? It just says less than 4. So open circle. And then I'm going to get a few more points here. Make sure, actually, and here you might, if you have different colors or a highlighter or something else, just to remind yourself, you might want to say, okay, the only x values I can have are less than 4. That's the only place I can have my graph. I can't go to the right of that. So I've got this point. Let's get a few points to the left of that. Specifically, let's see if the vertex is to the left of that. Because if I have the vertex, I really need to graph it. The vertex here would be +3, 2. Is everybody good? Or -2. +3, -2. Is everybody good with that? So again, opposite here, whatever's there. +3, -2. Here would be my vertex. So I know it's going to be a U shape that just kind of stops at that open circle. So let's get a few more points. You can make yourself a T-chart. You can do it in your head, whatever you're most comfortable with. I should have a corresponding point to this one over here at 2. If I plug in 2, 2 minus 3 is -1. I should get the same -1 that I got before. Let's get one more point. Let's put in 0. No, that's going to be, well, let's see. Let's see if I can put in 0. 0 minus 3 is -3. -3 squared is 9. 9 minus 2 would be 7. Does that fit on my graph? 1, 2, 3, 4, 5, 6. Oh, just barely. So there is 0, 7. And again, if you wanted to, you could plug in 1 and get that point as well. But what I'm looking for here is your graph coming down, hitting the vertex, being a U shape, and stopping at +4. Do make an arrow at the top, you guys, to show that this does keep going. It does keep going to the left and up. Now, what they're going to have you do, if we read all the instructions, and this is the way it's going to be on the test as well, it's going to ask you for the domain and range in interval notation. So the interval notation is just, for domain, is just a retelling of what they already gave you. We already said domain is everything below 4. Does that make sense to everybody? So we're just going to say that in interval notation. So negative infinity to 4. Can I include 4? So I've got an open circle. I don't have an or equal to. This should be a round parenthesis for that one. The range is a little different. You're going to figure out, okay, what's the lowest value? Well, it looks like that negative 2 at the vertex. Negative 2, and then it just keeps going up and up and up and up forever. So that means my range should be 2 to infinity. Infinity gets a parenthesis because I can never actually get there. How about the 2? Negative 2, thank you. So, Malik was first. Square brackets or round parentheses here? So square brackets there. We have negative 2. Does everybody understand that? All right, let's keep going. Pick up the pace a little bit. Straight lines. Straight lines should be easy. So again, you can always, I'm going to do this one with the erasing method. Just real fast. Negative 2x plus 3. It's already in slope-intercept form. So just find that intercept. 1, 2, 3. Down 2 over 1. Down 2 over 1. This would be the general line if I was just graphing it like normal. But it says, okay, f of 2 equals, well, if I plug in 2, negative 2 times 2 would be negative 4. Negative 4 plus 3 would be negative 1. That's this point right here. It says only where x is less than or equal to 2. So I'm actually going to erase the point that I had drawn down here. I don't need it. And only draw my graph going to the left of that point. Draw the arrow on the side there it keeps going. Draw the arrow on the side where it keeps going. Solid dot on where it stops. Now does everybody see that even though we were saying x is less than 2, we're picking the smaller x's, our y's are actually going up. Does that make sense to everybody? So domain, negative infinity to 2, and I'm going to include 2. Range, oops, put a round parenthesis where I didn't need one. Square bracket, looks like we're at negative 1 for the lowest value, up to infinity for the highest. Is this making sense to people so far? Any questions? All right, you'll get a chance to try this in just a moment. No, let's try it now. Why don't you guys try? That'd be a good one here. Oh well, that one's. You try number 1. If you're feeling adventurous, try number 3. They're both on the homework. 1 and 3 are both very simple, straightforward quadratics, like what we practiced in 1 and 2. Actually, don't try number 3. Number 3 is the exact example I already gave you on number 1. Everything is exactly the same. Oh, no, it's not. It's slightly different. There's one change. You can try number 3 if you want to. There's one tiny, tiny change. So watch out for it if you're going to do number 3. Any questions? or an important point. So f of negative 2. That just means plug negative 2 in. So what's negative 2 squared? Okay, remember that the square, yeah, you positive 4 because you do negative 2 times negative 2. So go ahead and write that down. Don't forget about finding the domain and range. After you've graphed it, find the domain and range. And I'll do it this way. So now, that's user on point negative 2, 4. And it tells you graph f of x where x is greater than negative 2. So that point is going to be your kind of your starting point. So where's negative 2, 4? Okay, so is there an or equal to sign? Or just a greater than sign? So you're going to put an open circle. And then your graph's going to come down because we're going to graph to the right of it. So you're going to come down, you're not going to have anything on this side. You're going to come down at that point. You might want to get at least one more point. So you've got, like that point would be there to come in near point. And you'd have its corresponding point on, or like near image point. And then this one would also have a mirror. Does that make sense? So you just come down, up at that point, draw your arrow. The whole rest of it is the same. And then you go back and say, okay, what's my domain and what's my range? The domain should be the same as this statement, just in interval notation. The range you have to figure out every time. Does that make sense? Are you okay with it? There's no equal to sign here, so you can't include the negative 2. It's your starting point, but you can't include it. Yes. No, you always do smallest to greatest, so that's exactly what we want. We're going from negative 2 to infinity and from 0 to infinity. So you got the point in the right spot. These points are good. But it's telling you that it only wants to graph that where x is greater than negative 2. So you'd start there at negative 2. And you come down at those points and then keep going up. And your graph would go from here on. It wouldn't include anything on this side. Does that make sense? Because the domain, negative 2, starts here at negative 2 and then goes to the right. Does that make sense? So the points you've got are perfect. You just don't want this part because it's to the left of negative 2. And you do want this part because it's still to the right of negative 2. You go to where x equals 1, right there, and you only get the stuff that's bigger than 1. Good. And then we'll have to end up without a vertex. Alright guys. A few of us are still having issues with the essentially figuring out which way to graph, so we'll pay attention to that as we go through. Again, I would highly recommend the whole highlighting underneath the graph to show you kind of where you're going. Does everyone understand that the domain restriction that they're giving us has nothing to do with whether your graph goes up or down? It just tells you, can I go to the left or to the right? And then the graph itself takes care of whether you go up or down. I don't know if that explanation helps or not. But the restrictions that we're dealing with here are always left to right domain, not up and down range. That's going to happen just based off of which part of the graph you're graphing. So let's look at the next one. I know that this is where we struggle the most at this point. We are still having a lot of trouble with these exponential graphs. So here, let's work in a different order this time. I'm going to start this time, and we'll see if this helps some of you, by looking at my domain restriction and saying, okay, x is greater than 1. I can only graph where x is greater than 1, so here is x is greater than 1. There's x is 1, and I want bigger values. If that's not enough for you, you guys, if that's not enough for you to be able to tell where you can graph, you can even highlight a section of the graph and say this part right here is where I can graph. I cannot put anything over here. Does that make sense to everybody? These values are all x's less than 1. I need x's greater than 1. So I don't know where I'm going to end up in that rectangle yet, but I know my graph needs to be over here. So from there, I'm going to plug in and find the important point to start off with. So 3 to the first power minus 4. Well, that's not bad. 3 to the first power is 3. 3 minus 4 would be negative 1. So I have my starting point at 1, negative 1. 1, negative 1. Is this going to be an open circle or a closed dot, class? Open circle. So, open circle right here. That's right on my line. That's where I get to start. And then I've got to go to the right. I don't know if it's going up or down yet, so let's go ahead and put in another point. Let's try 3 to the second power, essentially f of 2. 3 to the second power minus 4. Well, 3 to the second power would be 9. 9 minus 4 would be 5. So I get f of 2 gives me 1, 2, 3, 1, 2, 3, 4, 5, right there. Okay, I'm not going to be able to fit another point in here, am I? It's going way off the graph real fast. So even though I'm not going to graph it, I'm just going to think through real fast, where would the rest of my graph have gone? Well, I would have had an asymptote down here at negative 4. I would have been going along that asymptote, and then I would have been making my L shape go through those 2 points. Does that make sense to everybody? So I'm going to put it, I'm just going to draw it underneath the graph. Remember that a exponential graph would look like this. I'd have my graph down, my asymptote down here, be going down, and then I'd curve up like this. So does everybody see that we're cutting off that first half? And I'm just going to have that little piece. You need to have that in your mind when you draw the graph so that you get a graph that's reasonable here. We don't want a straight line. We want it to be curved and accelerating upwards, going up faster and faster. So as much as you can, kind of give this a little bit of a curve and then just get it going pretty much straight up. That's really going to be as good as you can get for this graph. Because by the time you hit those 2 points, it's already going up really, really fast. Does that make sense to everybody? All right, let's state the domain and range. I'm going to start calling on people for this because I need to know that we've got this down. And if there are mistakes or confusion, I want to catch it as soon as I can. So, Yuna, what would the domain be for this one? So that would be for the range. For the domain, I want left to right. So what's the farthest left value? I think, because you said negative 1, right? Okay, yeah, so it's not negative 1. It is 1, positive 1. Does that make sense? So positive 1, and Yuna, do I put a square bracket on there or a round parenthesis? Parenthesis. And then does it stop at all or do I go to infinity? Go to infinity. There we go. There's our domain. Range. Let's get somebody else. Raymond, what's the range here? Negative 1 to infinity. And do either of those get square brackets? Not quite. That negative 1 point is our open circle. Does that make sense? So still around parenthesis. Any questions with those, you guys? All right, I want you guys to try, where was it? I just found the one I wanted you to do. Number 11 on the homework. Oh, no. Number 7 on the homework. Number 7 on the homework. This one's a little bit simpler. It doesn't have a plus or minus on it. Go ahead and try that.
Bless you.
one's with you guys. I'm going to help you out, okay? For the initial point. The initial point. Who remembers that what 2 to the negative 2 power is? Right? That's the point that they asked you for. I've told you we're going to get to more of these later on. You're supposed to know this already, but we'll get a lot of practice later. Anybody remember your rules of exponents? It's a fraction. You're right. A couple of you said it. What is it? It's not an I. It is actually a real number. We'll get to those later. Anyone? What did you say? It is 1/4. So again, the negative exponent makes it the reciprocal. So 2 squared would have been 4. I saw a few people with that. The negative is going to make it 1/4. So graph that one as best you can. Graph 1/4 as best you can on there. And then don't worry about doing -1. I'd pick like 0 and 1 and 2. Get some nice points on there. Is it, or is it less than that? Okay, good. That's the only weird thing. If you've got that point, you should be good. So the one we were just talking about is number 7. Okay, so you've got a good point on there, and then does it make sense why I was talking to the class about that point? Okay. So again, they have you start at -2. And that -2 means you're going 2 to the -2 power, which a lot of us don't remember how to do. So that was why I went over that. 2 to the -2 power would be -1/4, or sorry, not negative, just positive 1/4. And that would be your starting point at -2 1/4. Just go up just a little bit, so you're just not even all the way to 1, because 1/4 would be kind of right there. Little marks there. So you'd start there, and then if you get like 0, you can plug in 0 or plug in one more point, and then make your graph. All right, take a look up here, check your answer. This is what it should look like. So here's the -2 1/4. That was the point that we'd said you have to get that one, but it's weird. So 2 and 1, -2 and 1/4. You can skip that -1 point if you want and just go right to 2 to the 0 power is 1, 2 to the first power is 2, 2 to the second power is 4. And we get the general shape of our graph. It's just starting right there. Now, even if you didn't do it yet, I'm going to have you, I'm going to call on a couple random people to get me the domain and range. Even if you haven't found it yet, you can work it out right now with us. Megan, did you get the domain, or could you tell us what the domain would be here?
-2 with a bracket and infinity.
That's perfect. -2 to infinity, including -2. Does everybody understand? Again, this is just a rewriting of this. These two mean the exact same thing. They should always match. Abby, can you tell me what the range would be? So we'll start with the, do you want help? Or, okay. So are we going towards infinity or negative infinity? Okay, is everybody good with our range going towards infinity? So I know that the end part's going to be this. You guys, if you're not sure about the range on the test, if you put that, you get 1 out of 2 points. Okay, so make sure you get those pieces. Now, the first part, though, where we're starting, this is our lowest value, isn't it? That's the farthest down. What was that point? -2 1/4, and the 1/4 is the y value, right? That's the lowest y value. That's what goes here. There will only be maybe like one like that on the test at most. It can come up. It can come up. But most of them will be nice whole numbers. So again, essentially, this is just from the f of -2 equals, that I did up on the board so it wasn't written there. F of -2 equals 1/4. That's our lowest point on the graph, and we have the rest of the graph there. All right, I want you guys to have a good chunk of time to work in class. So we've actually gone through enough at this point that you should be able to do the rest of the homework up through number 9. I don't see any issues with any of the problems before number 9. On Thursday, we'll cover what you need to be able to do 10 through 14. So the homework for tonight is 1 through 9. We've already done, what, 2 or 3 of them? 2 of them? So take the next 8 minutes. Take the next 8 minutes to get as much of that done as you can.